2x minus 1 to the 2/3 plus 2 times 2x minus 1 to the 1/3 minus 3 equals 0. So we can do this by substitution. You have to decide what to let your u equal. So what is my u on this one? Yes. Okay, then we have 2x minus 1 to the 2/3, that's u squared, plus 2u minus 3 equals 0. Any questions on that one? Okay, so then we can factor. So 1u squared, so we can do the shortcut. What multiplies to -3 and adds to 2? So let's go positive 3 and negative 1. So then set each of those to 0, and we get u equals -3 and u equals 1. Okay, are we all right there? Now our u was 2x minus 1 to the 1/3. So we plug that back in. A 1/3 power is just like saying a cube root. What's the opposite of a cube root? Cubed. So we will cube each side. So those cancel. And we get 2x minus 1. Negative 3 to the 3rd is negative 27. So you add your 1, divide by 2, and we get negative 13. So there's one answer. And what should you, especially on the test, take the time to do with these answers? Check them. Okay, I'm not going to take our class time doing that right now, but you've got a calculator, and you can always plug that back in and check. So we're going to work this one the same way. This is the cube root of 2x minus 1 equals 1. So if we cube each side, 1 to the 3rd is 1. Add your 1, divide by 2, and we get x equals 1. Okay. Let's look at problem number 8 on the handout. So we have 4x to the 4th minus 8x squared plus 3 equals 0. Okay, so we have two options. We can do substitution here. Probably the easier option, if you guys aren't scared of it, we could just do box method. It's not that ugly for the substitution. If you want to do box method, do I get to do the shortcut on this one? No, because it has that 4 in front. So you would have to do the full box. So we get 4x to the 4th and a 3. So if you multiply two things multiply to a positive 12 x to the fourth. And we need them to add to a negative 8 x squared. So what would it be? Right. And what variable do we put with each of those?
X squared.
Right. You had an x to the fourth, so if you split it in half, each of them gets x squared. So then we can factor 4x to the fourth and negative 6x squared. You take out 2x squared. So it'd be negative 1, 2x squared, and negative 3. Okay, set each of those to 0. So if we add our 1, divide by 2, how do you get rid of a square? Square root. When you do that, you have to include a plus and a minus. So x equals plus and minus. Square root of 1 is 1 over the square root of 2. Can you leave it like that? No radicals on the bottom. So multiply by radical 2 on top and bottom. So that's radical 2 over square root of 2, which is just 2. Work the other one. So divide by 2. Square root, plus and minus. Get the radical off the bottom, so multiply the radical 2. So that's plus and minus radical 6 over the square root of 4, which is 2. And those are the answers. Anything else from this homework that you want to talk about? Let's look at number 6. Okay, our radical problems. Our goal is to isolate the radical and then square to cancel it. Now, lucky for us, one of these radicals is already by itself. So we could jump right in and square each side. When you do this, you're squaring each side of the equation. So on the left, that means you have 2 of these. And you have to FOIL. So radical x plus 5 times radical x plus 5, what would happen? Right. You get a radical squared, so the radical and the square cancel, and we just get a plain x plus 5. Minus 2 radical x plus 5. Minus 2 radical x plus 5. Plus 4. On the right, you square a square root and it drops, so we have x minus 1. Okay, I'm going to combine like terms. So I have an x, 5 plus 4 is 9. Negative 2 and negative 2 would make negative 4 radical x plus 5. What do we need to do now? Isolate the radical. I'm going to go ahead and add my radical over just so it's a positive. It really doesn't matter at all. Then if I subtract this x, my x's actually drop. Add 1. Okay, so at this point, what could we do? You can, if you don't mind the fractions, go ahead and divide by 4. If you want to avoid the fraction, you can leave it like it is and square. You could divide both sides by 2 if you just wanted to put it in lowest terms, but avoid the fraction. So it doesn't really matter there. We do have to still get rid of my square root, so I'm just going to square as it is because I think most of you before preferred to avoid the fraction as long as you could. So that gives me 100. 4 squared is 16. So that's 16x plus 80. So subtract over your 80. Divide by 16. And x is 5 over 4. So a couple different paths we can take to get there. Is this okay? If you would just fold those assignments up together and put them front corner of your desk, and I'll collect them in a little bit. Now let's go to the study guide. So you've worked it. I posted an answer key so you know how you did. What do you want to work out on there? Or is there anything that you would like for me to work out on the study guide? So, what do we want to talk about on here? You understood everything perfectly on the study guide? Ask your questions, guys. I know you have some. What do you want me to talk about on there?
13.
Okay, let's look at 13. Okay, so we have negative 3i over 2 plus 5i. How did you do on those 4 problems, 11 through 14? In general, were those okay? That was this kind of section 1.3. It was a small piece of it. There's only 4 sections on this test, so one section is really right there, all the imaginary number stuff. Being able to add and subtract, multiply, divide, and then simplify those powers of I. So here's a division problem. What we have to worry about is if you have a fraction, you can't leave I in the denominator. So it's just like when you try to get a radical off the bottom, you have to multiply by the conjugate. So the conjugate is the exact same thing except you change the sign. So when I do that, I have to distribute, so I get negative 6i plus 15i squared. On the bottom, when you FOIL, you get 4 minus 10i plus 10i minus 25i squared. On these problems, every time you get an I squared, what does it turn into? Negative 1. So 15i squared is like 15 times negative 1, or negative 15. On the bottom, negative 10i and positive 10i cancel. negative 25i squared becomes a positive 25. So we get to this point. I said in the directions to write it in standard form. That's a plus bi. So your a is your real number part. So that's negative 15 over 29. Plus b is your imaginary part. So that's our negative 6 over 29, or you could just put minus, either way. I. So when I say give me an answer in standard form, make sure you are going ahead and doing that. So a problem with the fractions like this. We have to, our strategy was to get rid of them. You first need to make sure all your denominators are factored. So x minus 2, there's not much we can do there. X plus 2, nothing we can do there. What about the x squared minus 4? Mm-hmm. Okay, so now let's make a note for ourselves. What can x not equal in this problem? Right, it's anything that makes the bottom 0, so that's a positive 2 or a negative 2. Now, for the first fraction, it has an x minus 2, so if I want to cancel it, we multiply by x minus 2. If you do it to 1, you do it to all of them. So those would cancel, and these cancel. So we still have something left on the bottom, so we still have to multiply. Next thing on the bottom is x plus 2. So then those cancel, and those cancel. So at this point I'm left with, whoops, I didn't write it on my first one, did I? I have 3 times the x plus 2 plus 1 times the x minus 2 equals 12. So solve this, we get 3x plus 6 plus x minus 2 equals 12. So 4x equals 8 and x equals 2. And then what does that tell us? No solution. Because we said at the beginning that x couldn't be positive or negative 2. I want to talk about one more. I may not work it out in its entirety, but one more problem like this. There was one on, I think it was on the handout, but if I gave you something like this. Just want to mention something here. What can x not equal? Can't tell, work it out. You know 2x minus 3 can't equal 0, so 2x can't equal 3, so x can't be 3 over 2. So that's the thing to remember. To get rid of this first one, you'd have to multiply by 2x minus 3 squared. Don't forget, if you have a number by itself, you know that 6 isn't written in a fraction, that doesn't mean I ignore it. It still gets multiplied with everything. So if I multiply by the 2x minus 3 squared, those cancel, and one of these cancel. Do I need to multiply by anything else here? No, we've got rid of our fractions. We have 3 minus 6 times the 2x minus 3 squared equals negative 7 times 2x minus 3. Okay, so then you would finish it from here. But I just wanted to make sure you guys realize a lot of times I've caught if there's just a plain number, people aren't multiplying it. So make sure you don't forget about that piece. Let's look at, I had a couple questions on the study guide. Number 17 was like one of these. So let's go ahead and talk about it right here. Two over x squared minus 36 plus 1 over x minus 6. My guess is if you got this wrong, you probably missed there was a negative right there. Okay, first step, factor your denominator. X squared minus 36 is the difference of squares, so that's x plus 6 and x minus 6. What can x not be on this problem? Some minus 6. Okay. So to get rid of the first one, we have to multiply by x plus 6 and x minus 6. So that would cancel both of those. It takes care of my minus 6, takes care of my plus 6. So it gets rid of everything. So then in the first fraction, all you're left with is 2 plus 1 times anything is just that. So x plus 6 equals negative 1 times x minus 6. So if I add my x over, subtract my 8, divide, and you get negative 1. Somebody also asked on Google Meet about number 5, so let's talk about it real quick. How do you get rid of a square? Square root. When you do a square root, that's plus and minus. So you get 4x minus 1 equals plus and minus. The square root of negative 9 would be 3i. So then you add your 1 over. Divide by 4. I like standard form, so I'm going to put each of these over 4. So you get 1/4 plus and minus 3/4i. The question was asked if I would give you the quadratic formula. Problem number 6, you try to factor it and it doesn't work. You guys should know the quadratic formula, so I am kind of expecting you to know it at this point. If you need to, jot that down. So quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you might need to look that over if you don't know it yet. If I give you a problem with a radical that you have to isolate it and then square to cancel it, we did one on the homework. Do I need to do another radical problem, or you guys know how to handle that? Good with those? Substitution problems, we did one on the homework. Let's say I gave you this one real quick. Let's say x minus 5 squared minus 2 times x minus 5 minus 35 equals 0. So on this one, you would have to do what? You have to do the u. What's u going to equal? So then this is u squared minus 2u minus 35 equals 0. Right? We can do the shortcut box method because it's a 1u squared. Multiply to negative 35 and add to negative 2. Either way, it doesn't matter which way you write them. Okay, set each to 0, so u is negative 5 and u is positive 7. Then plug back in, u was x minus 5 to begin with. So if you add your 5 over, you get x to equal 0 and 12. So those were the three types of problems in section 6. The fractions, where our strategy is to get rid of it. The radicals, where we isolate and then square or cube if it's a cube root. And then the substitution problems. Section 3 was the imaginary number stuff, like 11 through 14. We did all of the quadratic stuff. So like 4 through 10, we're all solving quadratic equations. So you know problems like 4 and 5. It's easy to get that or the square part by itself, and then you could just square root. 6, you have to do quadratic formula. Same on 7. You can do box method on those problems. What about number 10? You don't need to do quadratic formula, but you can't do box method. You only have 2 terms. What do you do here? Greatest common factor, take out an 8x. Then you set each piece to 0. So we get 0 and 1/2. Okay, so you guys are okay on solving the quadratics? Let's just talk about some word problems then. That's the last topic we had in here. So we had a few different types. We had like geometry word problems. Something where we might be able to draw a picture. I didn't put one quite like this on the study guide, so let's see if I can just make up one. You guys trust me? Let's say we have a field. We have a rectangular field. With a length let's say 40 more than the width. All right, and will be fenced off with 3 inner divider fences. Parallel to the width. There is 220 feet of fence. Find the length and width. What do you do on a problem like this? Draw a picture. We have a rectangle. Okay. I know my length is 40 more than the width. Do I know what the width is? So that's going to be x. My length is 40 more than that, so it would be x plus 40. Okay, then what does this mean? 3 inner divider fences parallel to the width. What's that saying? We are going to put 3 more fences in here. They're parallel to the width, so they run this way. So what's the length? What's the length of each of those? X. So all of those are x. This is x plus 40. When I talk about the 220 feet of fence, what's that represent? Perimeter. So we have to add all of these. Because I put fence on the inside too, I'm not just adding the outside. After a curveball at you, you have to get the inside too. So I have 1, 2, 3, 4, 5 of those. Okay. Then I have 2 of these. You could either write it twice or say 2 times the x plus 40 equals our 220. Subtract over your 80. Divide by 7 and you get 20. How should you answer all of these? Always write a sentence at the end. For the sake of time, I am not going to write a sentence, but you would. I wanted the length and width, so my width is 20 feet. My length, 20 plus 40, would be 60 feet. We did distance problems on here and mixture problems. Both of those we set up in a table. What's the distance formula? Good. And there was one of those on the study guide, so I'm probably not going to work that out. And then the mixture problems, maybe I'll just run through setting up one of those if you want. Do we need to go through a mixture problem? Like the percent one, so on your study guide number 17. Oh, do I have yours? The numbering is off on my answer key. I don't know if that was the case on yours.
17, and then once it gets to the part where it says solve each equation and make sure to check each answer, it'll say 17 again. So
Okay.
It's just 18.
Yeah, my numbering's off. So I wonder when somebody asked about 17 earlier if they were talking about the first number 17. Let's just run through setting this one up real quick, and that'll probably be the last one I work through. I'm going to hand back the quizzes that you guys turned in to me the last time I saw you as well, and go over any questions there. So this one was a mixture problem. Remember the percents, or how we set that up? We did our percent times, in this case we were talking about pounds, or sometimes I call this the amount, times concentration. So you might have put those in a different order. It doesn't matter. equals the amount pure. So on this one, we were mixing 7% hamburger with 15% hamburger to get 10%. Remember, your total, the one you're getting, always has to fall in between the others. 10 falls in between 7 and 15. Okay, it says how many pounds of hamburger, that's 7%, so I don't know, so that's my X, must be mixed with 30 pounds of hamburger, that is 15, to get my hamburger, that's 10. So what would I put down here?
30 plus 10.
What if I'd said you had 30 in your total? What if I said I wanted to get 30 altogether? What would you put right here? If my grand total was 30, that meant when I add those two together, it has to equal 30. So my missing piece would be 30 minus X. So, you know, I might have given you that you wanted 30 pounds in your final mix. So you might have had to do that. Okay? Then the percents, if I said 7%, what do we use for that? 15% and 10%. So then you just multiply. And the nice thing about these, you add the first two to equal your total. I'm going to hand back these quizzes. I'm not going to work out the equation from there. I think it's the setup that probably got you more than anything.